Hello, my name is Oluwademilade and welcome to the AI programming task that was given. So for my game, I've got my Boyd's working. The Boyd agent responds about 700 assets into the scene with the right animations on them. And then if my health is less than the maximum, then the player goes around chopping down, the wanderer goes around chopping down trees, which increases the wood by 20 each time. So once it's done in this state, then it would start patrolling the scene. But before then, I'll just show you what the things my scene. I have my hero impute, which lets me control the hero the way I want. I've got the sounds in my scene as shown in the first clip. I muted it for these clips in order to be able to hear the explanations I'm giving. And then also the campfire reacts to what time of day it is. In the daytime the campfire goes off, and in the nighttime the campfire comes on. So around 8 o'clock in the morning this should turn off. The particle system of the campfire should go off, and there you go, the campfire light goes off. And then looking at, if we go back to the wanderer scene, which is using the final state machine, also for my enemy scene, which is using the behavior tree, the enemy agent, if it patrols the scene and then once it sees me, it follows me. If it gets close enough, it will attack me, which will reduce my health. But now that my wood is at the maximum, if we find my wanderer, it's just gonna wander around the scene while this follows me around. And for my hero complexity, if I go next to a base, it should increase my health gradually, but at the same time reduce the amount of wood. And if the wood is at zero, then it wouldn't increase my health. To start my scene, you can see that the wanderer agent we use is a final state machine starts with the harvest state, but you can see if it gets in contact with the enemy, it flees away from it. But once it's out of range, it goes back to harvesting. It goes back to the harvest state, which is basically trying to get wood to 100. And once the wood is at the maximum, you would see that it will start patrol, just wandering around the scene. So now that the wood is at 100, you can see that this just uses the A-style pathfinding to go around the scene. To start with, in my agent script, I have a reference to a couple scripts that I need to use, a couple arrays for the waypoints and the tree list. So because this covers for all the states, so I just put the functions that I'll need the public of the variables of the public that I'll need in the agent, and then they are referenced into the respective states. And basically, and also to start my agent, the initial state at the start of the game is the idle state, because if I put any other state, my code gets buggy and it breaks. So I just have the idle state, which does nothing. And the only time my agent is in an idle state is when the game starts. After that, it's never in an idle state. And then in the update state, I have if the sensor dot hit is false and the tree is not the maximum and we're not already in the wonder state, then change the state to wonder state. And it's basically the same idea for the other two states. If the tree is less than the maximum and not already in the harvest state, go to the harvest state. But if the sensor is true and we're not in the flee state already, regardless of the amount of tree in storage, it doesn't matter, just flee away. And the way I've done the wonder is basically I've created the wonder function. We basically find a random point out of the array that we put into the agent, and that function is called in the enter. So on entering the state, you already know what waypoint you're trying to move to, and then if the boolean moving is false, then start the pathfinding with the target being that point that we just found, and using the pathfinding method that we used. And then if the distance of the agent is close enough, then wonder, find a new point, and then obviously it won't be close enough anymore, then it would basically just replay this and go to that new point over and over again. And in the harvest state, what I have here is basically a find new tree. So in the harvest state, on entering the state, we're going to move towards the tree we're trying to cut down. So we have a function for finding a random tree of our list, and then this function is to move the agent towards the tree by starting the pathfinding algorithm, and then that is called in the enter function. So it moves towards the new tree, and in the execute, if this is false, then this is basically to reset the game object after it's been destroyed. So this is like if it's within range and the tree's health is still greater than 0, then take damage to it. But if it's less than, then we add the current value the value of the tree, and then if it's already equals or maximum, then the current will always equal the maximum. In the flee state, there's only a bit of code in the execute where the agent moves in the opposite direction of where the enemy is at that point. And also for the enemy agent as well, it's got a similar thing where the enemy is gonna be patrolling the scene, but if it comes in contact with or if it detects the player, I'll just make it detect the player, then it finds the player, goes towards the player, and starts playing the attack animations, which actually affects my health, as shown in the videos before. But there is a bug on my code on my agent, because it starts pathfinding, but once it finds the agent, if the player, if the player is out of reach, it doesn't go back to a pathfinding state, it just stays on the spot it was the previous time. The way I started my behavior tree for my enemy agent was by drawing this diagram, which was halfway completed, but it was just as a start, so I understand how exactly I was gonna code this. So that's basically what is being done here, from adding the root node, which is a selector node, to adding both the pursue node and the patrol node, which is sequence nodes, as child nodes to the root node. And then for each function in each of the different states, they get added as child nodes to the sequence nodes. I'm talking about the leaf nodes. For each leaf node, it gets added to the right child node, sequence node, and then all this is just done, and then I just created functions for each of them, which finds the random point, moves to the wonder point, check if the distance is less than what I'm looking for. If I can see the player, I store of its position, then moves towards the position. If I'm in position, then attack.